Hi everyone, I'm Vanessa Hall. I'm a firefighter in Ocean City, Maryland, and today I'm going to be talking today about my CS109 project, which is detecting mental health disorders in first responders. So let's get into the problem. First responders see traumatic events daily. And because of that, rates of PTSD, anxiety, and depression are much higher in this community. But the tools we use to screen for these issues, like the Personal Health Questionnaire 9 or the General Anxiety Disorder 7, rely on Likert scales from 0 to 5 or 0 to 3. In fire and EMS culture, where stigma is still really strong, people tend to anchor their answers in a lower range rather than selecting the accurate number. That leads to low accuracy and a lot of missed cases. So my project asks, can we build a screening method that's less sensitive to stigma and doesn't rely on people perfectly rating themselves on a 0 to 3 scale, but rather just a binary yes or no? Okay, so let's look at the data. To build the model, I used DSM-5 aligned symptom data, which is a general mental health screening test. I cleaned it so each disorder only used the symptoms that actually belong to that disorder, and that dramatically reduced noise and makes patterns cleaner. So I trained one logistic regression for each disorder, anxiety, depression, and PTSD, and I used over 2,000 individuals' responses for training with their diagnoses and around 1,000 for testing. Logistic regression works well here because instead of just saying, positive or negative, even though that is the binary classification I do give in the end, it also gives a probability that someone meets certain criteria using that sigmoid squashing function. And that is what lets me build risk categories later. So let's look at the results. The models actually performed really, really well. For depression, sensitivity was 100%, so it detected all true positives and it only had one false positive. For anxiety, sensitivity was also 100%, and then that one had 7 false positive, which makes sense because anxiety symptoms are common even in people who don't meet the full criteria, so having a few more false positives isn't really an issue. And then lastly, PTSD was a bit trickier because of that synthetic data, and it came out to around 86% sensitivity when it was tested on a deliberately noisy synthetic data set because I didn't want to, create overfitting. But across the board, I was really just focused on sensitivity because in mental health screenings, it's much safer to flag someone that might not have the disorder than to miss someone who needs help. And you might be wondering where I get the threshold cutoffs for predicting someone having a mental disorder versus not, such as the sigmoid greater than or equal to 7 in this slide. And so I used calibration curves for that. And so to turn those raw logistic outputs into a sort of risk level, these calibration curves came really in handy. They showed how predicted probabilities match the actual outcomes. And using that, I created buckets like low, moderate, high, and very high possibility of the disorder, which is really a more realistic diagnosis than just a flat over 0.5, let's cut off to classifying as a 1. Now moving on to naive Bayes and information gain. I also used naive Bayes to calculate information gain, which basically means what symptoms are the most informative or what questions provide the largest reduction in uncertainty about whether someone has a disease or not, mental health disorder or not. For anxiety, the 6-month duration question stood out immediately. And I thought that there was something wrong with the model because it had such a high information gain and such a high logistic regression weight as well. But the reason that this happened was because you must have symptoms for 6 months to be clinically diagnosed with anxiety. So from these information gain graphs, I can see how the models are recovering diagnostic requirements, which I think is really, really amazing. So now here is the web application that I built. Instead of using Likert scales with severity, people just answer simple yes or no to symptom questions, and the model returns a calibrated probability and a risk category. It's not meant to diagnose, but rather it's meant to give departments an early screening tool that's actually designed for first responders instead of the paper tests. And in the end, using CS109 topics, I found that we can build more accurate and more stigma-resistant mental health screening tools by using symptom-level data and machine learning. Hopefully this approach helps departments identify issues earlier and supports their responders better. Thank you.